can. All right, so the electrons that are most important in determining reactivity of an atom are the valence electrons, the one on the outermost shell. And we'll discuss that when we talk about electrons later on. But right now, it's important to just understand that the outermost electrons are important. They're called valence electrons, and they allow things in a group to react in a similar way. What's a group? You say a group is a column on the periodic table. So this is one group here, and this is the second group here, and there's the transition metals, their own rules we'll talk about in a minute. Then the boron and the carbon and the nitrogen, oxygen family, right? So these are all groups. So anything in the halogen family acts like anything in the oxygen family acts the same. Nitrogen family acts the same. And then there's the noble gases. The noble gases, kids, the Kardashians of the periodic table. Everything on the periodic table wants to be like the noble gases. We don't understand why. It's just true. Actually, we do understand why, but it's just a joke now. Anyway, it's not a joke, actually. This is totally taken over my lectures. It used to be a joke, and then everyone thought I was serious, and now the Kardashians, as you can see, are part of the curriculum. All right, so as we discussed, valence electrons are based on how many electrons you have in the outside ring, and the number of them determines that everything reacts the same. So group 1 all have 1 valence electron. Group 2 all have 2 valence electron. Group 3, 4, 5, all the way up to 12 are the D block. We'll talk about that later. All right, but group 13 have 3 valence electrons, group 14, 4, group 15, 5, 6, 7, 8. So if everything wants to be a Kardashian, right? If everything's trying to be a Kardashian, then how close or far away they are from a Kardashian determines what they're going to do. It's true. So if everything wants to be a noble gas, then they basically want what's on the outside. So metals, we've discussed this. Now, this is something we did discuss. Here's our staircase. Everything to the left of the staircase is a metal, correct? All the metals, it's true for every one of the metals, they tend to lose electron, because look at this. Potassium, which is right here-ish, hydrogen, lithium, sodium, potassium right here. So here's potassium. Potassium's right here. It has 1 valence electron, all right? 1 valence electron, there it is. If it were to lose that valence electron, the next shell down would have 1, 2, well, let's even count it with little numbers because I can. 1, 2, 3, 4, 5, 6, 7, 8. So now it thinks it's a Kardashian. It's got the same outfit on as a Kardashian, right? It's got its Yeezys, so it thinks it's good. So 8 valence electrons makes potassium think it's a Kardashian, and so for that reason, it tends to lose that electron. It's just like, well, goodbye. If I lose you, I get to be like a Kardashian. And because it lost a negatively charged electron, it has a charge of +1. Okay, magnesium, same situation. Magnesium has 2 electrons here in the outermost shell, right? It's got 1 up here and 1 down here. If it loses those, now it also thinks it's a Kardashian. 1, 2, 3, 4, 5, 6, 7, 8. All right, it thinks it's neon Kardashian. So losing 2 electrons helps magnesium think it's a Kardashian, and because of that, it gets a charge of +2, right? It lost 2 electrons. It still has 12 protons because that's what makes magnesium magnesium, and potassium still has 19 protons because that's what makes potassium potassium. So it still has 12 protons. However, because it has lost 2 electrons, it's a +2 charge. Non-metals, things on the right side of the periodic table, oxygen and fluorine and chlorine and such, they tend to gain electrons. They're 1 away. Look how close fluorine is. Fluorine is so close to being a Kardashian. 1, 2, 3, 4, 5, 6, 7. Oh, it's so close to being dressed up like a Kardashian. So it grabs 1 more to have 8. Now it has 8 electrons. It thinks it's a Kardashian. It's still fluorine. 9 protons. It's still fluorine, but because it picked up an electron, it's now a negative charge. I should probably erase that so you can see that nice negative. All right, so fluorine becomes -1 because now it has an extra electron, right? If it didn't have that electron, it would have 9 and 8. So when I say 9, there's 2 in the lower shell there. Okay, so 7 and 2 is 9. But by picking up 1, it has now 10, and 10 is like neon, so fluorine is -1. Oxygen has 6 in the outer shell, 8 total, 8 protons. That's what makes oxygen oxygen. So 8 protons. It has 8 electrons. 6 of them are in the outer shell. 1, 2, 3, 4, 5, 6. It wants to dress up like a Kardashian, so it wants 2 more. Boom, boom. There they are. So we got 7 and we got 8. Now oxygen has become oxygen minus 2, right? Because 8 protons, now it's got 10 electrons, so it has 2 more electrons than protons. So oxygen becomes oxygen minus 2. Now, having told you all that, let's practice Kardashian charges. If we look on our periodic table, we'll see sodium has 11 protons. So look at your periodic table, see where sodium is, has 11 protons. It's going to want to be like the Kardashian with 10 electrons. So I guess I'm going to need to actually go to a periodic table to give you this full thing here. All right, so here's a periodic table. Here's sodium. Sodium's number 11. So it can either go all the way across here to get to be like the Kardashian argon, or it can go backwards 1 because it has 11. It can go backwards to 10 and be like neon. It's much easier for sodium to go backwards to neon. So getting back to our little chart here, sodium will have a charge of +1 because it'll be like neon when it has 10 electrons and 11 protons. So let's look at bromine. Bromine, I tell you, is number 35. So we can go right to the periodic table. Here's number 35. What's bromine going to do? Is it going to go forward to be a Kardashian, or is it going to go backwards to be a Kardashian? It's going to go forward and become like Chloe, right? So bromine's going to gain 1 electron, become like krypton. And in doing so it wants to be like krypton, it's going to have a charge of -1 because it picked up an electron, and the total number of electrons it's going to have are the same as krypton, 36. Okay, so its electron count will be 36. It has to keep 35 protons or else it'll become something else. But because it has 36 electrons, it has a charge of -1. Calcium. So now I don't even tell you how many protons. You got to go figure it out. So you go over to calcium. You go over to calcium. There we go. Go over to calcium, and it's number 20. And number 20 tells you it has 20 protons. So we know that much. We have 20 protons. All right. Now, what's the charge going to be? Well, let's take a look at calcium again. So calcium's here. Does it want to go all the way, this long way to get to krypton? No. It can go backwards too. 20 can go backwards to 18 and become like argon. That's much easier. So it wants 18 electrons to be like the noble gas argon. We figured that out. 18 electrons to be like argon. So what's the charge going to be if it has 18 electrons and 20 protons? That would be a +2. So calcium would have a +2. What about aluminum? What about aluminum? So let's go look at aluminum. Aluminum's right here. Aluminum is number 13. So what does that number 13 tell you? Number 13 should tell you that it is 13 protons. And then what is it going to want to do? Well, aluminum's here, number 13. It can go forward 5 to get to argon, or it can go backwards 3 and get to neon, right? So 13 goes backwards to 10, that's 3. 13 goes forward to 18, that's 5. So it's easier to go backwards to neon. So we got neon is what we're trying to be like. Neon has 10 electrons, and therefore this must have a +3 charge. That is the background that I hope you understand.